Hi everyone, in today's lesson we are going to be learning how to solve quadratic equations by factorization, and that will be the key learning objective of today. Before that, we need to recall a few concepts that we have learned before, either this year or previous year. Firstly, what exactly is a quadratic expression? Next, we also want to recall how to factorize quadratic expressions. Thirdly, we want to recall what's the difference between expressions and equations. And finally, how do we solve linear equation? You may find this slide quite familiar because you would have seen this same slide in our lesson for quadratic factorization, where we recapped on what is a quadratic expression. So in essence, a quadratic expression is something where by the unknown itself, the variable has a power of 2 in it. So in the examples over here, we notice that in the expression, the highest power we see is power of 2. So there is x squared term or y squared term, depending on what is the unknown. And then for non-examples of quadratic expression, we have things like x plus 7 and x, or 2y and negative 8. Because we see that there is no power of 2 in any of the terms in the expression itself. So that helps us to do a very quick recap on what is a quadratic expression. Then we also recently learned how to factorize a quadratic expression using the cross method. So in this case, which is 3x squared plus 10x minus 8, which you also find again very familiar from the previous lesson, where we use the cross method by drawing a frame like this, placing the terms in a certain order, where we have 3x squared plus 10x and minus 8. Then after that, arranging them accordingly in such a manner. Then in step 2, we determine the factors that could achieve the terms found in the bottom row. So in this case, we need to decide what are the two things to be filled up over here that will multiply with each other to get 3x squared. And then for the second column, we also need to determine what are the two things that will multiply to give us a positive 8 first. I said positive 8 because the negative sign, will come into our consideration later on. So in this area, don't forget we're doing multiplication. So hence, we have 3x times x to give us 3x squared. 2 times 4 to give us a 8. And then we do our cross multiplication in this manner, where we take x times 2 to get 2x, and that will help us fill in this space over here. Then 3x times 4 to help us fill in this space over here. Then keeping in mind that this final row, or rather this final column, is supposed to add up to give us positive 10x. So that can only happen when I have a negative 2x and then also a positive 12x. This is where step 4 comes in to determine the signs. Because of the negative sign and the positive sign over here, we will then have a negative sign here and a positive sign over here. And this makes sense because in this column itself, the multiplication of negative 2 and positive 4 does give us a negative 8. And that is our step number 5, which is to check that each column is multiplied or added correctly. That is how then we get the answer to the factorization of 3x squared plus 10x minus 8. Then we also want to recall what is the difference between expressions and equations. The past 2 chapters, we have been dealing with expressions, where we expand, otherwise we factorize expressions. We have learned this concept back when we were in Sec 1. So the difference between an expression and an equation is that in an expression itself, we observe that there is no equal sign, there is no value being attached to this entire phrase itself, this algebraic phrase. Whereas in equations, there is an equal sign and there is a value attached. So for example, this expression here is given a value of 0. Then for 3x minus 5, the value that has been given to it is 9. For negative 8y, the value given to it is 24. And for a squared minus 24x, the value given to it is negative 36. in these equations itself, it may not all be solvable, okay, within our means now, right? For some, we may be able to learn it, okay, from today's lesson, but for the others, we may not be able to do it. Okay, for example, 4a squared minus 24x equals to negative 36 can't be solved at this juncture based on our skills. Okay. Next, we want to recall what is the difference between expressions and equations. We have covered this concept last year when we were in Sec 1, but today I want us to be able to recall and draw the distinction between expressions and equations. So in expressions itself, we have examples such as this, and in equations, we have examples such as this. What is the difference that you notice between the things found on the left column and the things found on the right column? I hope that you notice some difference. In expressions itself, there is no equal sign to it and there is no value attached to it. Whereas in equations, there is an equal sign and there is a value being attached to the algebraic expression. So for example, x squared plus 6x plus 5 is actually a quadratic expression for which, if made into an equation, we could equate it to 0 or it could be any number. But essentially, in an equation, there is a value given to it. Then, in 3x minus 5, it is actually an expression, and in this case, an example of an equation is that we equate it to 9. Then, an expression of negative 8y, okay, if I were to make it into an equation, I could perhaps make it into equals to 24. It really depends on the question itself, okay, but this is an example of an equation. Then we also have 4a squared minus 24a as an expression, and if we were to equate it to negative 36, that actually becomes an equation. Okay, so there are a few examples of equations such as 3x minus 5 equals to 9 and negative 8y equals to 24, whereby we know how to solve already. Because these are linear equations, the highest power of the unknown is actually a power of 1. Just that we do not intentionally write in the power of 1. Whereas for equations such as x squared plus 6x plus 5 equals to 0 and 4a squared minus 24a equals to negative 36, these are considered quadratic equations, which is what we will be learning how to solve in this lesson today. So this brings us very nicely to the next thing that we want to recall is how to solve linear equations. So for example, if I have 2x plus 1 equals to 4, in order to solve any equation, the thing that we want to do is to end up isolating the unknown on one side, meaning to say I want to find the value of 1x. But we usually do not write 1x, we just write a single x itself. So to achieve that, we will bring this plus 1 over to the right. To be more precise, we are actually balancing the equation by subtracting by 1 on both sides of the equation. So when we subtract by 1, a positive 1 minus 1 will give us 0. Hence, we get 2x equals to 4 minus 1. And that simplifies to 2x equals to 3. Then, we divide both sides by 2, and that will get us the answer of x equals to 3 over 2. I hope that you find this process familiar because we have learned this in Sec 1 as well, okay, in terms of how to solve linear equations. The main thing that we want to learn today is how do we solve quadratic equations. And these are some examples that we will be going through in examples 3, 4, and 5. Before that, we want to know, or rather we want to learn what is the zero product rule. So for example, if I were to tell you that a times b is equals to 0, what can we say about a and b? Let us pause here for a moment to think about what could the numbers a and b actually be. Do you agree that either one of a or b must be equals to 0? Because in order to have the result of a product to be equals to 0, one of the numbers must be 0. We cannot have two non-zero numbers to multiply with each other and yet get 0. That can never happen. Okay, so that is what we mean by the zero product rule. So whenever we have two things multiplying with each other and it is equal to 0, we can confidently say that either A, otherwise B, or it could also be both numbers that are equal to 0. Okay, so that will be the key thing that we are going to apply whenever we solve quadratic equations. Now let us take a look at solving this equation and how is it that we can apply the zero product rule. Firstly, this is a quadratic equation because if I were to expand this, I would get x squared minus 3x. And that is actually a quadratic equation since we have a quadratic term of x squared. So in this case, we are just trying to learn how to apply the zero product rule. And with this question, we see that it is a product of two things, and that is x versus x minus 3. So the two things are x and x minus 3. So given this question itself, and using the zero product rule, we will be able to conclude or to be able to next do that x is equals to 0, otherwise x minus 3 is equals to 0. Okay, and in this step, we are actually applying the zero product rule. So x equals to 0 is already a solution because we have already achieved the single x on one side. However, we have another solution which is x minus 3 equals to 0. But this is not yet completely solved. So with x minus 3 equals to 0, we will then need to write x equals to 3. So what we're trying to do here is that whenever we get a linear equation as a result of our zero product rule application, we need to actually solve the linear equation whenever there is any. So we see that there are actually two solutions over here. When x equals to 0, I do get the left hand side to be equals to 0 in the end. But when we see that x is equals to 3, we also see that the right hand side will be equals to 0. So we conclude that the two solutions would then be x equals to 0 or x equals to 3. So at this juncture, I want us to take note that for any quadratic equation, we always have up to two solutions. It is not possible for us to have 3 solutions, but we have a maximum of 2 solutions. In other words, we can have one solution or sometimes no solution. Okay, so we will be slowly exploring such cases whereby there is one solution or no solution at all. But we will first start off by having situations that allow us to get 2 solutions. Okay, so whenever we have an answer blank in our exam or in our test, we are expected to provide both solutions. It is not that we can just provide only one of them. We have to write both, okay, and they are separated by the word or, because both solutions may not happen at the same time. Okay, hence any one of them happen when any one of them is happening, we already will get the value of 0 on the right side. Let us move on to an example 2. So what if I want to solve 4x squared plus 6x equals to 0? This is a quadratic equation since we have the quadratic term of 4x squared. So with this question over here, we need to actually see it as a product of two factors. But the way the question is being phrased doesn't allow us to see a product of two factors because we have 4x squared plus 6x instead of multiplying. So the way to go is to see that this expression on the left could actually be factorized by taking out the common factor of 2x and be left with 2x plus 3. So when we factorize, we see that we have 2x multiplying with 2x plus 3. Okay, so there are two things over here for which when we apply our zero product rule, we can say that 2x is equals to 0 or 2x plus 3 is equals to 0. This is where I applied the zero product rule. So then, because we see that 2x equals to 0 is not yet at the final stage because we want x equals to something, so to solve 2x equals to 0, actually it is just x equals to 0 because we need to divide by 2 on both sides and 0 divided by 2 will be equals to 0. Then we move on to the second linear equation here, 2x plus 3 equals to 0. And the first step we have to do is to write 2x equals to negative 3, where I shift the positive 3 to the right. And then x equals to negative 3 divided by 2. Hence, we get this other solution from this linear equation. So what we're trying to do here in both sides is that we're trying to solve each of the linear equation since there are linear equations for us to solve. Hence, in conclusion, for this question, the solutions will be x equals to 0 or x equals to negative 3 over 2. Next, we take a look at example 3. We want to solve 3x plus 7 times x minus 4 equals to 0. In this question, it is already in its factorized form. We see that there are two things being multiplied with each other. The first one being 3x plus 7 and the second one being x minus 4. So using our zero product rule, we have 3x plus 7 equals to 0 or x minus 4 equals to 0. And that is where we apply our zero product rule. Then we focus on each of the linear equation that is being produced. So looking at 3x plus 7 equals to 0, to solve it, I can have 3x equals to negative 7. Hence, x equals to negative 7 over 3. We try to keep our answers to exact, hence I'm not going to write it in 3 significant figures or a decimal. Then x minus 4 equals to 0 will then be solved to say that x is equals to 4. So this process is where I am solving a linear equation. And therefore, my solution to this equation itself is two solutions, and that is x equals to negative 7 over 3 or x equals to 4. Next, we look at example 4, where we want to solve 2y squared plus 7y minus 15 equals to 0. So in the past three examples, we see that in order for us to apply our zero product rule, we must have two things multiplying with each other. So with our quadratic equation over here, we recall that any quadratic expression could be factorized using the cross method, or at least for as far as we can. Okay, later on when we move on to set 3, you may realize not all quadratic expressions could be factorized, but that's another day for us to talk about. Okay, so at this point, it will surely be factorizable, right, for which we do our cross method, and this is what we do to do the factorization. Okay, I hope that you are already familiar with this, hence I'm speeding up the cross method itself. So from the cross method, I see that I have 2y minus 3 as one of the factor and y plus 5 as the other factor. So now I have a product of two things, and hence I can do my zero product rule and get 2y minus 3 equals to 0 or y plus 5 equals to 0. So that is applying zero product rule. Then we focus on solving each of the linear equation. So for the one on the left, we get that 2y equals to 3, and hence y is equals to 3 over 2. And then y plus 5 equals to 0 will lead us to y equals to negative 5. So that is how we solve linear equation. Therefore, y is equals to 3 over 2 or y equals to negative 5 would be the two solutions to my quadratic equation here. Next, we look at example 5. This is 9n squared minus 12n plus 4 equals to 0. Since we have already gone through 4 examples, you may wish to take a pause over here to try this question yourself and see whether you are able to get the answer or not. So now let's take a look at how to solve this equation. So given 9n squared minus 12n plus 4 equals to 0, we will do our factorization using the cross method as shown here, which is sped up. And then we get 3n minus 2 times 3n minus 2 equals to 0. Of course, you can say that 3n minus 2 equals to 0 or 3n minus 2 equals to 0 by using our zero product rule. However, we know that 3n minus 2 and 3n minus 2, they are the same. So actually we could simplify this to writing 3n minus 2 bracket square. Okay, so this is our factorization process where we simplify it into this stage. Although it is in a squared form, not to worry, we know that we can take square root on both sides of the equation to say that 3n minus 2 will be equals to 0. Okay, while it seems that we have an extra step over here, actually we don't quite, right? So it really depends in the first place how is it that you did your factorization anyway. Okay, so we are taking square root to lead to this linear equation, and hence we get 3n equals to 2 and n equals to 2/3 when we solve the linear equation. Therefore, in this particular question, we see that instead of having two solutions, I'm getting one solution of n equals to 2/3. The reason why we have only one solution is because our two factors over here, they are actually the same. Okay, so that is one of the reasons why n is equals to 2/3 is the only answer to this equation here. When you explore in A-maths in Sec 3, you may learn a more generic method, okay, to find out whether a quadratic equation has how many solutions itself. But that is left for another day, or in fact another year for us to discuss, right? So I will not dive into that. Okay. So now that we have seen that the way to factorize, there's many ways. Okay, we could actually use the cross method, which is our generic approach, or you could use the identity, which is what we have just been learning about. Otherwise, if you were to look at example 6, I hope it rings a bell on the way you want to factorize. In fact, if you are familiar and well versed in how we solve equations, you may realize that there are actually two methods of solving for this equation. We will start off with the first method, which is by factorization, and that is the way that we have been doing in the past 5 examples. So given the question here, okay, we notice that 25 is actually a perfect square, likewise 9 is a perfect square. So I'm going to use the a square minus b square formula that we know to actually factorize this quadratic expression. So with a being 5x and b being 3, applying my identity, I will get 5x minus 3 times 5x plus 3. So in this process, I'm actually applying this identity, this formula over here. Now that it is written in this manner, I see that I have two things that are multiplying with each other. That is 5x minus 3 as well as 5x plus 3. So using the zero product rule, I can say that 5x minus 3 equals to 0 or 5x plus 3 equals to 0. Hence 5x equals to 3 on the left side and x equals to 3 over 5. That is our solution from the left equation. Then on the right equation, I also do the same, and I will find that x is equals to negative 3 over 5. That is another solution. So we see that we have two solutions, 3 over 5 and negative 3 over 5. So this will be how we solve it by factorization. I want you to start thinking whether how the second method could possibly look like. So in our second method, we are actually going to balance the equation, meaning to say that when I want to add something, subtract, multiply or divide, I need to apply it to both sides of the equation. So given this question here, what you could consider is to bring the 9 over to the right, or to be more precise, I'm actually adding 9 on both sides of the equation such that I arrive at this equation. Then x squared is equals to 9 over 25. And we know that we want to find out a single x, so x squared is not correct. So to find out what is x, I will take square root. And when I take square root, there is both positive as well as negative. Hence, you can key this into your calculator, meaning to say to key in square root 9 over 25 without the plus and minus sign. So the first solution will be 3 over 5. The second solution will be negative 3 over 5. How I got negative 3 over 5? Because this plus minus sign means that I have one option that is positive, the other option is negative. Okay, this is not a Chinese character, it is the plus minus sign. So with that, we have learned how to use factorization to solve quadratic equation. And I want us to observe that all the equations that we have been solving have been equals to 0. And that will lead us to think about, is it possible to extend the zero product rule to maybe 2 product rule? 3 product rule or maybe a million product rule. So let us think about it. If I were to tell you that A times B is equals to 2, what can you actually say about A or B? Is it necessary that either one of A or B must be equals to 2? So must I have 2 times something in order to get 2? We know that this is not true because I can have 1/3 times 6 to give us 2. I'm not talking about trying to figure out the factors. A and B need not be whole numbers. They need not be integers. We know that to multiply two things, I can have things like 1/3 times 6, and that gives us 2. And we see that neither 1/3 nor 6 are actually equals to 2. So we need to keep in mind that this is the zero product rule. So on the right side of any quadratic equation, it must be equals to 0. If it were not to be equals to 0, I cannot say that A is equals to 2 or B equals to 2. And that will lead us to our next example for this one over here. I think I may have a typo. And this leads us to an example 7, which we have a quadratic equation over here, and that requires us to solve x times x plus 1 equals to 6. So in this particular case, we notice that on the right side of the equal sign, it is actually 6, it is not equals to 0. So what can we do, and how do we solve such a quadratic equation? So to solve such a quadratic equation, we need to first expand it to get x squared plus x equals to 6, and then have it written as x squared plus x minus 6 equals to 0. So essentially what we're doing over here is to arrange into the standard quadratic form, okay, and then have the right side or one of the side to be equals to 0. So now that we have it expressed this way, and very importantly with one side being equals to 0, I can proceed to do my factorization, which I will speed up over here, hence writing it here already for my cross method. And that allows me to get the factorized form of x plus 3 times x minus 2 equals to 0. So then we can apply our zero product rule, and that is x plus 3 equals to 0 or x minus 2 equals to 0. So we say that x equals to negative 3 based on the linear equation on the left, and x equals to 2 based on the linear equation on the right. And therefore, we have two solutions to this question, that is x equals to negative 3 or x equals to 2. Let's try another example where we want to solve 2y minus 1 times y minus 4 equals to 9. So earlier on, we mentioned that we cannot say that one of the factors is equals to 9 because it is the zero product rule. So what we need to do is to expand the expression on the left hand side of the equal sign. That will lead us to 2y squared minus 8y minus y plus 4. That is done via our distributive law, otherwise known as your rainbow method. So that will be equals to 9. We need to have one of the side to be equals to 0. So what we will do is to subtract 9 on both sides of the equation, or in other words, 9 shifting over to the left, and that will give us a minus 9 over here. So with this, I can simplify it to get 2y squared minus 9y minus 5 equals to 0. So again, in this process, I'm actually rearranging the equation such that it arrives at the standard quadratic equation form with one side of the equal sign to be equals to 0. Then we do our cross method in order to get the factorization of 2y plus 1 times y minus 5, so that we can apply the zero product rule to get 2y plus 1 equals to 0 or y minus 5 equals to 0. Then solving the linear equations individually, I will get y equals to negative half from the left equation and y is equals to 5 for the right equation. And therefore, there are two solutions to this equation, and they are y equals to negative half or y equals to 5. I hope that you managed to understand the concept that we have been covering so far and be able to apply the zero product rule whenever we want to solve quadratic equations. So congratulations, we have come to the end of this video. Okay, you have completed learning how to solve a quadratic equation by the factorization method. There are many methods which you will be learning when you turn Sec 3 next year. I'll see you again in class. Bye bye.